Hi, and welcome to day 14 of Just Start Programming, creating console terminal apps using Rust and Ratatouille. Today, let's revisit logging with tracing and understand it more. Let's start from the basics and see how far we can go. Join me once again live in one take, no shortcuts and no secrets. So let's just start programming. All right, welcome back. So, our topic for today is all about logging and tracing. So, I think in the previous stream, I opened up this website. The author is Joshua Mong. Let's try to go through this blog and see what we can learn from this one. So from the Ratatouille website, the example is this. However, I think it's quite complex. So there's so many things going on here. You have customized macro, which I don't understand. And this one, there's this file tracing subscriber. So last time I was trying to do a tail. As you can see, we have this file created. However, there was nothing there. Okay, so let's start from scratch, at the very beginning. Hopefully this blog could help us understand more what is logging and tracing. All right, so let's start. Okay, so when println, debug, and ePrintline don't cut it, having a way to structure your logs is extremely important, especially production grade applications. This article will help you gain insight on what the best log crate for your use case is when it comes to Rust logging. How does logging work in Rust? In short, loggers in Rust depend on a library to act as a logging facade, a crate which provides a logging API that the logger can work with. So for example, if you have a crate like log that provides a logging implementation for us, we can use with logger, we'll also need to add a crate that actually carries out the logging. For example, simple logger being one of the many crates that can use log. Some logging facades may only be able to be used by their own special logger. For example, tracing either requires you to use a tracing subscriber crate. Oh, I think that's what was here. Tracing subscriber. or otherwise implement your own custom type that implements tracing subscriber. Without further ado, let's start the Rust logging crate comparison. Okay, so log. A log is a crate that calls itself a lightweight logging facade. The crate defines a logging facade as a library that provides a single logging API that abstracts over the actual logging implementation. Essentially, this means that you'll need to run another library that provides the actual logging, and then use this crate to provide the logging message. Log is also maintained by Rust core team and is probably the first crate you'll see on the Rust cookbook. Rust cookbook. Where is this? Let's see. Rust cookbook. Oh, this one looks a bit different from the Rust lang book. Okay. Let's see if we have logging here. Log message. Okay. So log a debug message to the console. The log crate provides logging utilities. The env logger crate configures logging via an environment variable. The log debug macro works like other std-fmt standard formatted string. No output prints when running this code. By default, the log level is error, and any lower levels are dropped. Set the Rust log environment variable to print the message. Macro prints the debugging information, then the following line at the very end of the output. Okay, maybe we try this one first. Can we reuse this? CLI arguments. Okay, so maybe let's open a new one. Cargo new logging tracing. Okay, so let's start with this. Create log. We do that cargo add. cargo add env logger. Cargo add env underscore logger. Okay. Then let's run this. What happened? No output prints. Okay. By default, log level is error, and any lower levels are dropped. So we have to set the log equals debug and cargo run. Okay, what happened here? Now we have debug, log tracing, executing query, drop table students. Executing query and string value. Okay, so we have drop table students. And this is the function. So it's just appending it to this one using log debug level. How does it work? If it's error, okay, by default it says it's error. So let's try. Maybe there's error here. Okay. Save, and then here, instead of setting Rust log, so the document says it's by default error level. There. Error. Okay, so that is using the crate log. All right, let's stop here and come back to the previous blog. So one step at a time. Okay, as taken from the GitHub repository, here's a simple example on how it can be used. GitHub repository. Which one? Okay, never mind. Use log. You have a function, shape the yak, and then reference to a mutable yak. Maybe if this is a struct, or we don't know what it is. And then log trace. So this one looks familiar. Log error, or maybe you can have log trace here also. Log trace. Okay. Let's put it back to error. Then you have a loop. To find a razor, then of course the important part is this one. So it will just print a log. Okay. It should be noted that log is also compatible with a lot of logger crates. Your GitHub repository alone lists of 20 and is a non-exhaustible list. If you're looking for a versatile logger, this is definitely for you. However, it's also not as powerful as some other crates, so there's that to bear in mind. For most common use cases, this is the easiest to use. Great. You simply set the message level and then send your message. A quick summary: maintained by the official Rust team, works with nearly all logger crates, not as powerful as some other log facade crates. Okay, what was it being recommended here also? We have it here. And this one is purely tracing, I suppose. Tracing error, tracing subscriber. Well, there's log here, but this is just the variable. Okay, so everything here is tracing subscriber. Okay, then let's continue with this. The next one is env logger. env logger is a simple Rust logger that's easy to use and is quite convenient for any small project where you want to implement logging but don't want something heavy duty that will more likely require a considerable amount of boilerplate. It's owned by Rust CLI working group, meaning it'll see long-term support, which is great for us. Rust CLI working group. Okay, maybe they're focusing only on CLI. It can be set up in one-line statement. Logger from default env. Then you'd simply run your program from cargo like so, with the Rust log environment variable in front of the command. Okay, so this one is similar to this one as well. Logger, but how do we use this? env logger. Okay, Rust CLI, official working group, then env logger. Okay, so we have to add this one. Let's do that. Add it here, env logger. Okay. So env logger must be initialized as early as possible in the project. After it's initialized, you can use the log macros to do actual logging. Oh, it's already here. Okay, so they are related. Info. Okay, so because you have log info here, then here you can just use info. So that is actually the same as this one. Info. Okay. Log. Okay. It can be set up in one-line statement. Okay, let's try this as well. So we don't need to have init, perhaps. Maybe let's comment this out and see. Logger, but then how do we use logger? Use logger. Logger. Like that. this quick fix. Okay, because we're not using it. So logger dot error. Oops. Logger dot is it supposed to be like that? Okay, this one. No. Then here, okay, here. V logger from env. How is it different from this? From default env. From default env, without having to use the env type explicitly, the logger will use default environment variables. Open. That's it. Okay, by default, the env will read the following environment variables: Rust log and Rust log style. Okay. Okay, coming back to this one. So default env, or you can have env new and you can provide your own environment variable. Okay, assuming we use the default env, then what's next? Have an overly verbose grade that allows spitting out logs. You can also set the log level for a specific dependency. This one looks different. Okay, let's come back to the code. How do we use logger here? I don't know. I don't know how to use this. That logger. Let's close this one and maybe somewhere here. It's not there as well. Non info. Uh, Examples. Okay, so here we have the environment also. env logger init from env logger. Okay, but env logger is not used somewhere else. So does it mean if we just anywhere in the code we just call execute query without doing this? Okay, so let's try. Cargo run. Nothing happened. Info. Okay, so let's try info. Info. Because it says that default env will be relying on Rust underscore log. So hopefully it will pick up this environment variable. Nothing happened as well. What's wrong here? Did I miss anything? env event logger. Okay. Maybe this. Copy. It looks wrong. env is from here. env logger env. We did not use that. Here we have logger. Logger doesn't mean we can just use logger. That's methods. These methods will each construct a logger immediately initialize it as a default global logger. Builder. Let's see what is here. It stopped here. That's the same as this one. Does it mean we need to set this one? Copy plus 2 trace run. Is it correct? Okay. Default is trace. So some trace log should show up. But why did it show everything? Did I miss anything? We just put error. Okay, so error. It should display error only. Okay, then warning should display warning and error, I suppose. Okay, so that's the log level. Then what's the other one? Info. So we should have 3. And debug. So info will show everything. No, not info. Trace. Yeah, but that is using env, then init from env. But if we do it like this, logger. How about we copy this, put it here. Env logger. Find function. Rust log. That doesn't work as well. Here you have a builder. Env logger builder. Custom default format. I have no idea. Wait. Env logger struct. Oh, We have, okay, so logger is a struct where you have the writer and filter. 3 implementations. Log. This is record. Let's put this back. Logger. Oh. Note that enable is not necessary for this method. Implementation of log should perform all necessary filtering. Then this is record. Okay, so I don't think this is the right way of doing it. Why it was mentioned there. Okay, so let's not waste our time on that. Instead, this is good enough. So we can have our own environment variable, and then we initialize it with that environment variable, and then we can just simply do trace, debug, info, warn, or error. That message equals to string from should have some value. Can we do something like that? Trace. Okay. So let's stop there. Let's come back. Have an overlay verbose crate that allows spitting out logs. You can also set the log level for a specific dependency. This is in conjunction with the log crate. Okay, now here we have builder, then level filter, and you have builder new, then you use the builder filter module. Okay, so this is what is it? Log message, or it could be a pattern. And level filter info and wrap. Path to module. Let's see. This one is also builder. Builder from env, format level. Okay, so this one doesn't have filter, maybe here. Filters from code. Filter level. This is filter module. Which one should we follow? Path to module. Let's put it here. And wrap. Import. Oh, maybe the second one. Log level filter. And wrap here. Let's comment it out. Builder. Okay, so that's just the builder. What's next? And it stopped there. Where can we find some examples? Okay, so this one. Builder new max. Okay, let's try this one. Connect should not be called after the logger initialized. Okay. Should not be called. Let's comment out this one. It was the example again. So we don't need this. Right, so let's see. I think it doesn't matter if you put my log level there. Okay. So it takes the max. So if we remove max and change it to what do we have there? Error. Let's start with error. So we have an option there. It's either it's inside the code, or you can set it via environment variable. Okay. Let's come back. So it's good to know that we have that option, builder pattern, level filter. This one is also quite interesting. It looks like I don't know, some form of regular expression, it seems. Okay, let's continue. For all of its convenience, however, env logger does suffer from a couple of things that you might be looking for in a production grade application. Namely, that there is little documented functionality on writing your own pipe for logs, which can make it quite tricky to implement. And it's also unclear whether this crate is thread safe. Issues. Other issues. Is this library thread safe? Needless to say, it's an extremely useful crate for any quick and dirty logging. A quick summary. Owned by Rust CLI working group, simple to use and feels good to use. Lack of documentation on more complex functionality like log appending and piping. Okay. Some unclear issues on whether the crate is 100% safe. Okay, then the next one, log4s. No, log4rs. It looks like log4j. Let's see. Is it log4j? Log4j. Yeah, log4j. Log4j for Java. Yes. So Log4j is an open source Java-based logging framework developed by Apache. In this case, it's log4Rust, I suppose. Highly configurable logging framework for Rust. Let's see what's in here. Log4rs. Okay, so there's a YAML file. Refresh rate 30 seconds, appenders, std out, console. Okay, you have the pattern here. Root, warning, appenders, std out, loggers. Okay. And let's come back here. Java sub4j. A logging package, that's probably one of the most deployed pieces of open source software. This crate requires a bit more setup than the others, and configuration can be done with either a YAML file or programmatically. Log4rs is compatible with log. It's good to know. Which is great for us, as it means we don't have to adopt a new paradigm. Just use log4rs. If you wanted to create a config file to load in from, you'd set your YAML file like this. I think that's the same as this one. Then the encoder can either use JSON encoding or pattern encoding. Here we have decided to use pattern encoding, which follows similarly to the original log4j pattern, but with Rust string formatting. You can check out more about how to format your encoder pattern here. Okay, so it follows log4j, so maybe we can make use of this documentation. Then you can just initialize it when you're setting your program up, like so. Init file, you need to point it to the YAML file. And you can also programmatically create your configuration. So instead of YAML, then you can do something like this in code. Okay. You can also automatically archive your logs with log4rs, which is great. Archive your logs. What does it mean? This is a feature that must otherwise be manually implemented by yourself when it comes to most of, if not all other logger crates. So having this feature built into the logger itself is a huge convenience. You can get started with setting it up by adding the following to a YAML configuration file under appenders. Appenders here. Rolling appender. Okay, does it mean that it will rotate the logs according to this policy? Okay, policy 10 MB. Upon reaching the max log size, the file simply gets deleted on successful run. So it will be deleted. Okay, so yeah, so it depends on the policy. Now we have a policy that fills up the main log, then appends it to an archive log file. What's the main log, which has 10 megabytes. Then deletes the currently active log file ready to receive more logs. Oh, okay. So it will actually exactly does it behave? It fills up the main log file up to 10 MB, then appends it to an archive log file. Does it mean only to one archive log file or several files with date or time or number. Then it deletes the currently active log file. Deletes the currently active log file and ready to receive more logs. So what does it mean? It creates a new log file. Okay. As you can see, log4rs is an extremely versatile crate that works with previously mentioned log crate to provide powerful functionality with regards to logging in Rust, and is especially great if you're coming from a language like Java, where you already understand the mental model and just want to find out how to do logging in Rust. However, in exchange for this, you have to learn how to set up the logger up, and the setup itself is quite complicated compared to other logging crates. So bear that in mind. Okay, so why not we do okay, so if you do, okay, this is only configuration. It did not show the example. Here. We can try this out. log4rs.yaml. Let's create a file. Refresh rate 30 seconds. And how do we use it? Config. Maybe we need to create a folder. Config. Then remove this one here. Then this one. We need to add cargo and log4rs. log4rs. Okay, let's see. Cargo run. Okay, so something was created here. That's not log. Log requests log pattern. Refresh rate. What does it do then? Refresh rate 30 seconds. Refresh rate. Okay, so this one, it means you need to understand how to set it up. Yeah, that's 30 seconds. I mean, booting up. Can we do a loop? Can we do a loop over here? Loop. Oh. Something. Endless loop. Let's see. Maybe now's the perfect time to do a tail. Some power Ratatui. No, it should be tracing. And let's have breakfast. Wait. Maybe we need to change the configuration. Not just uh, 5 seconds. Let's see what happens. What? Epic fail. STD out kind console. This is info. Okay. Maybe if we use warn, would that work? Warn. Okay, let's leave that as info. Warn B. Let's put warn as well. At least we'll see something. There you go. But this one is okay. We're missing something. Appenders. STD out. Warn appenders. STD out. Kind console. Kind. std out. Oh, what was that? Root level 1 appenders std out. Okay, so maybe that's why it was shown here. This is console. Okay, so let's change it a little bit. Can we change it here? Maybe requests. So this is YAML. We can insert requests. Let's try this. Okay, tail. Here. Our dangerous loop. There. Yes. So at least we're getting something. Where's my system monitor? There. It's getting crazy. Right. Yep. Okay, so that's how it is. Let's explore the other ways. Okay, policy tracing. So what do we have here under tracing? Tracing Tokyo. Tokyo RS. Application level tracing for Rust. Tracing is a framework for instrumenting Rust programs to collect structured, event-based diagnostic information. Tracing is maintained by Tokyo project, but does not require the Tokyo runtime to be used. Okay, so now this is the same as this one, I suppose. Tracing subscriber. Okay. Tracing subscriber. Then create and install a subscriber. Subscriber init. At number of yaks equals to 3. Info number of yaks preparing to shave yaks. Number shaved equals to yak shave or number of yaks. Let's cargo. Okay, let's do a cargo add tracing subscriber. Here. Cargo add. So I should add tracing, I suppose. Nope. Cargo add tracing. Tracing subscriber. So tracing version 0.1.41, here is 0.3.20.41, so it's not that far. 0.3, okay. Minor version, they're the same. Okay. So this one should work. This is copy and paste programming. Paste. Put everything there. Shape. Could not be found in registry index. Okay. What is this? Tracing info. Where is this yak shave coming from? At number shave equals 10. Okay, so let's run that one. Cargo run. Okay, info log tracing. Tracing, preparing to shape VX, number of VX 3. VX shape completed, all VX shape equals false. Okay, at least we are seeing something. So that's for tracing subscriber. Using init calls set global default, so the subscriber will be used as the default in all threads the remainder of the duration of the program, similar to how loggers work in the log crate. For more control, a subscriber can be built in stages and not set globally, but instead used to locally override the default subscriber. Tracing subscriber format. Subscriber. Setting it to trace. Build but do not install the subscriber. Finish. And here subscriber with default subscriber info. This will be logged to std out. This will not be logged to std out. Okay, let's try this. level trace level. Should it be log level or tracing level? Let's try tracing level. Info logging tracing. This will be logged to std. This will not be logged to std out. Is it because info is where? Info. And then the setting is trace, so it will show everything. But although this is info, but it is outside the subscriber. If we put something like this. It is already moved. Okay. What can we do here? Subscriber to what? Let me clone. Let me do that. Tracing. I'm just stubborn like that. Anyway. So if we put it inside the subscriber, then it should show up. This is trace. Maybe we change it a little bit. Maybe this one. Set it to info. Let's try it that way first. Info. Initially it won't be logged, but now it's going to be logged to std out, because of the subscriber. the level is debug, will it include info? Okay, it will include info. So let's change it to warning. So this is warning, but we're setting it to info here. So in terms of log level, warning is here. So it should not include info. Yeah, it was not included. This part was not shown. But if you change it to warning, warn. Oh, there's no warn. Tracing warn. So now this one will be included. There, info warn. Okay. So you're subscribing to the tracing subscriber. So it's by events. Any trace events generated outside of the context of a subscriber will not be collected. This approach allows trace data to be collected by multiple subscribers with different contexts in the program. Note that the override only applies to the currently executing thread. Other threads will not see the change from with default. Once a subscriber has been set, instrumentation points may be added to the executable using the tracing crates macros. Now this is the one with the macro. Where's the macro? Or is it referring to debug info macro? Warn debug. Okay, let's try to understand this one. In libraries should only rely on tracing crate and use the provided macros and types to collect whatever information might be useful to the downstream consumers. Tracing instrument. What's going on here? Okay, so there's debug. Info. That's all. Is there an easier explanation? Okay, so here it mentioned tracing uses the concept of spans, which are used to record the flow of execution through a program. Events can happen inside or outside of a span, and can also be used similarly to unstructured logging, that is, just recording the event any which way, but can also represent a point in time within a span. Event. Something happened. Read the span while entering it. Tracing span. Enter. Records an event within my span. Where's my span? happen inside my span. Spans can form a tree structure. An entire subtree is represented by its children. Therefore, a parent span will always last as long as its long-lived child span, if not longer. Because all of this can be a bit excessive, tracing has also included the regular macros that would be in the other log SAD libraries for logging, namely info, error, debug, warn, and trace. There's also a span version of each of these macros. But if you're coming from log and want to try tracing out without getting lost, I think, yeah, I definitely got lost. This tracing concept is way more advanced. It introduces these events and the scope of event by having this span. Tracing's got your back. Info span. Tracing subscriber is the logger crate designed to work with tracing by letting you define logger that implements the subscriber trait from tracing. You can start a subscriber that take the Rust log environment variable like so. Registry. You can also apply a hard-coded filter programmatically. So it has event filter, level filter, tracing subscriber init. So this is just initialization. You can also layer filters on top of each other. This is quite useful in case you want the effect of having multiple subscribers at the same time. If you need to export your log somewhere, there is also tracing appender crate. You would want to add this in with your tracing subscriber by using with writer method, like so. Let's come back to what was the code this time? Sample Ratatui. No, not this one. That's it. I think it was in CLI arguments. Yeah. CLI arguments. With file, with line number, with filter. This is just the initialization. Maybe this part is not necessary. Let's continue looking into this. So this is still init. So tracing subscriber is a logger crate designed to work with tracing. Yeah. Yeah. That was the hint again. It has to be inside the span. Or something like this. So it means it should be inside this file subscriber. So we need the subscriber. Subscriber. Tracing subscriber. Tracing subscriber. Or default init. Tracing file. Then you have file subscriber. From file subscriber, then inside that one you can do these things info. We need the macro here. Tracing event. It could be this one. Trace debug. Rust versions. Okay, so I think we exceeded the time. What I will do in the next video is let's go through tracing once again. Let's see what we can learn from tracing subscriber, and then we revisit this one again. So it will take us another day, another session. But then after that, we can move into other recipes. Terminal and event handler. Right, so let's end here. I hope you learned something as well today. And see you in the next live session or in the next video. Before that, let me thank my support.